Hi everyone, today we're going to be looking at the photoelectric effect experiment, and from this experiment we'll be able to see that all the wave characteristics of light that we've talked about before this is not able to account for some very peculiar properties that we can observe through the photoelectric effect. Before we talk about those strange properties, we need to be able to talk about the setup of the experiment first. So this is how the experiment basically looks like. We have this circuit, which is made out of a variable EMF supply, which we are not going to worry about first because we're going to set it at 0 volts. So there is no supply or no EMF coming out from the supply. We have an ammeter, and we have two plates, a photoemissive plate and a collector plate. We will explain what these two plates do in a while. We keep these two plates within a vacuum chamber, right? So there are no other air particles which will interfere with our experiment over here. Outside of this vacuum chamber, we have a monochromatic light source. Monochromatic light source basically means that I am only allowing light of a single frequency to be emitted from this source. Light from this source is going to hit the photoemissive plate, and what it's going to do is it will cause electrons to receive energy from this light, and once the electrons receive enough energy, they will be able to eject from this plate, and they will fly towards the collector plate. When the collector plate receives these electrons, the electrons will then be able to travel through the circuit. Will travel right through, and this ammeter here will read any current which is traveling through the circuit. As the electrons reach return to the photoemissive plate, they will then repeat the entire cycle again and again as long as the light is incident upon it. Let's talk about two major factors or two things that we can change about this monochromatic light source. The first thing that we can change or we can alter using our understanding of light as a wave is the brightness of that light or the intensity of that light. We are going to first talk about red light. So if I have red light shining on this photoemissive plate, at the beginning I shine a very weak light upon it, and you can see that the wave I'm drawing is a very, very small wave. But I can increase the brightness of that wave, and if I do that, then my wave will grow bigger because I'm using a much larger wave. So the amplitude of that wave will become bigger. Now remember what we say about a wave. If the wave becomes bigger, or the brighter I make the light, then I can assume that there is more energy in that wave, right? Because that's how waves carry energy, in the largeness or the amplitude of that wave. So if I have more energy in the wave, then the electrons which are within this photoemissive plate are going to receive more energy, and they're going to be ejected from the plate with a high amount of kinetic energy. So I get a lot of electrons coming out because I have a lot of energy from the light. This is what it would suggest. More energy is given to the photoelectron. And the suggested observation would be I have faster moving electrons, or I have more electrons coming out from the plate itself. Okay, so that's the first expected observation. The second expected observation, if light is a wave, is I can also manipulate its frequency, right? At the beginning, I use red light, that's light of a low frequency, and I can increase its frequency to say that of a violet light, right? Now, the thing is this, if I'm manipulating frequency, then if light is a wave, then I'm not actually changing its energy, right? And if that's the case, if I'm using a particular intensity of light, regardless of what frequency it's going to be, all frequencies then can release photoelectrons. So the suggested observation would be there is no change. There is no difference in whatever frequency that I'm using if I keep the intensity of the light the same. So, what do you actually see from the photoelectric experiment? Let's first look at the brightness. If I change the brightness of it, remember previously I should be getting more and more electrons coming out if I'm increasing the intensity of the light. But I realize that the kinetic energy of the electrons don't change. In fact, if I'm using red light, if I shine red light on it, and if no electrons come out, no electrons come out at all, then no matter how bright that light is, no matter how big I make the wave, there won't be any electrons coming out at all. However, if I were to increase the frequency of the light, say I slowly increase it, I increase it to orange light, still no electrons come out. I increase it to yellow light, still no electrons come out. But the moment I hit a certain amount of frequency, and we're going to be talking about this in a little while, let's just say blue light, and straight away I can see electrons coming out. I note that there are some electrons coming out. And as soon as I reach a certain color of that light, and some of you might be able to see where we're going here, if I increase the intensity of that light, I start making it brighter and brighter, then I get even more electrons coming out. So we can see that once I pass a certain color of that light, if I increase the intensity of the light, I get more and more electrons coming out, right? So what does this mean? It means that maybe, just maybe, when I'm increasing the brightness of that light, I'm actually creating what seems to be more and more smaller, more and more of these small wave like particles, so to speak, which are hitting this this plate over here. The brighter it is, the more waves, the more wavelets I get hitting this plate over here, and the more electrons I can get coming out. So light is basically made out of these discrete packets of energy, right? The next thing we look at is the frequency of that light. And just now, like what we've said, if we have red light hitting this plate, or we increase the frequency to say orange light hitting that plate, somehow or rather I don't get any electrons coming out, no electrons coming out from this. But once I pass a certain frequency of that light, say for example, once I pass yellow, once I pass green, and I hit blue light, all of a sudden I get an emission of electrons. Straight away I get this emission. So what happens is this: there are no electrons which are released below a certain threshold frequency. Red light, no electrons. Orange light, no electrons. But the moment I get into a certain frequency, let's say blue for example, then immediately I get electrons released. So what's the explanation over here? The packets of energy that we talked about previously, all those small wavelets that you see, have an energy which is proportional to the frequency of that light, right? So the two things we've learned is this. Number one, light seems to be captured in discrete packets of energy. And secondly, the more packets of energy I have which are incident on this emissive plate, the more photons I have coming out. Thirdly, the energy of that light seems to be proportional to the frequency of that light, because below a certain frequency I don't get electrons. After I hit a certain frequency and beyond, I get these electrons coming out all of a sudden. And the greater I increase the frequency, the greater the kinetic energy of these electrons which are moving across from plate to plate. So in summary, we can say several things. The classical physics model of light as a wave can only explain reflection, refraction, diffraction, and so on and so forth. But in order to explain the photoelectric effect, we can no longer depend on the wave model of light. We can only model it by light particles, which are called photons. These photons are basically discrete bundles of energy, which are proportional to the frequency of the light, which is given by this equation, E equals to hf, where E here is the energy of the photon, h is Planck's constant, and it's given by 6.63 times 10 to the power of negative 34, and f here is the frequency of the electromagnetic wave. All of these things were basically pieced together by Einstein himself. He looked at all the limitations of light as a wave model. He looked at the results of the photoelectric experiment, and he was able to piece together this equation, which we will talk about in greater detail in another video.